Welcome back. We had a nice meal break there. Feeling good and refreshed.
Refilled, ready to go.
Yeah, ready to talk some more Unity. So in the next few modules, we're going to be talking about the Windows Phone.
That's right, yep.
Yeah, we'll take a closer look at what we can do to support the Windows Phone.
Yeah, some of the features that we can take advantage of once we port over.
What we have to do in order to pass certification as well. We'll talk a little bit about live tiles, and then we're going to finish up with some splash screens.
Yep, so that's the next 3 modules, basically.
Yeah. Very good. Okay, so yeah, let's jump right into supporting Windows Phone. So for the overview for this module, we're going to be taking a closer look at the Unity and Windows Phone. We're going to take a look at actually building our Windows Phone build. We'll talk a little bit about using accelerometer for input. And finally, we'll finish up with looking at how to handle the hardware back button presses, which is a requirement to pass certification.
Right.
So I thought, first off, I know a lot of you out there might not have Windows phones. So I thought it might be a good idea just to take a minute and just kind of show you what a Windows Phone looks like. So if you see here, this is my Windows Phone. You've got your live tiles, a lot like your start screen on the Windows Store, or Windows 8 rather, sorry. And just got your basic features, and of course the back button. I don't know if you can see that very well there. Yep. I'm pointing to the right side. There's a back button, and it's a hardware back button, and that's the button that we want to support in order to be able to pass certification. So yeah, I just wanted to give you a quick overview of what the phone looked like and what we're going to try to do with it today. Okay, so with the phone, there's some hardware details that I thought we should run through. First off, this is something that a lot of people aren't completely aware of, so I wanted to pass along this information. Is the Windows Phone has a detailed minimum hardware spec.
Right.
And what that means is any device that is supports Windows Phone 8 must at least match these minimum specs.
Right, and they've had this in the past. If you did work on Windows 7, they had the minimum screen sizes that they supported and so on.
Exactly.
Same kind of idea.
So if you're looking to to find all these minimum hardware specs, we've included a link in the slides. So if you download the slides, you'll be able to click that link, and it'll give you a little bit more detail into what's expected of the minimum hardware anyway. A couple other things: Windows Phone 8 devices, they support hardware acceleration with a programmable GPU, which is really nice for us game developers.
Yeah, that's right. Take advantage of some extra power there.
Exactly. They do use DirectX 3D with a feature level set to at least 9.3. So if you want, of course, we've stuck a couple more links in here, but you can go ahead and take a look at a great table that's on the MSDN website that'll actually show you the features supported by each level.
Right. And you can just compare, make sure what you want is at that level, and then you can put that as your minimum.
Yeah, exactly. So yeah, when we mentioned before about the fog, right? And it has to be supported on a minimum of 9.3.
Exactly. So if you can put that right in your description even for your game that, it could be runnable without fog or with fog. In a lot of games, it's just an added feature, but at least now you can make, it known somewhere in your app description basically that those features are supported only on these newer phones, but the game will still work maybe on a phone previous to that version, just without the fog or something like that.
So yeah, the Windows 8 devices, they also come in 3 resolutions. So you've got your 480 by 800, which is also known as WVGA. Yep. You've got 768 by 1280, which is known as the WXGA. And you have your 720 by 1280, which is also known as 720p.
Right.
To find the resolution of your device, this is actually pretty simple. You can just do a quick query to screen.width and screen.height to actually get the property values for inside of your Unity scripts.
Which is the way everybody does it.
Yeah, it's the same on all devices, right? So that's really nice. So you can find out what device screen resolution you're running on.
Yeah, there's nothing specific there for the Windows platform or anything that you have to do.
Memory on the Windows Phone devices comes in a few different configurations. First up, you've got the 512 megabytes of RAM for the WVGA devices.
That's right.
You have a minimum of 1 gig of RAM for the 720p devices. And in fact, the newest phones, such as like the new Nokia 1020, has up to 2 gigs.
Right. And I mean, again, you got to keep that in mind, depending on what platforms you're going support, or you might want to detail that again, that your game only runs in certain ones and so on.
Actually, we'll get to that in a minute because you can
Exactly.
actually do something that'll opt out of that.
Yes.
So yes, Unity projects by default opt into the ability to use the lower memory. So we say 512, but actually you're only going to have access to 180.
Right.
So that's something to keep in mind. You think to yourself, well, I've got 512. That's pretty good. I should be able to run my game and spawn those millions of trees in the forest that I've put in my game. But the truth is, you only have 180. You have to share that with the rest of the OS and other devices, right? Or other apps that are running on the device. So by default, you're opted into this lower memory. You can opt out of this by selecting inside of your capabilities in your app manifest that you require. So it's ID underscore REQ underscore memory underscore 300 capability. Again, that's a mouthful, but if you opt out of it, then what that says is you're only going to run on devices that have above 512.
Correct.
Right?
Yep.
What else is really good about that is if you're on a device and you're in the Windows Store and you don't have above 512 and you've set the capabilities, those users aren't even going to see your application.
Right, which is good. Then you don't get anybody accidentally buying it or downloading it.
And giving you bad
complaining.
reviews and stuff like that because you didn't support their hardware.
Right. So it's nice that that's automatically a feature of the store itself. It removes those kinds of problems from the user base.
Exactly, right? So, it takes a little bit of the stress out of being a developer and worrying about, meeting all those. Again, you can learn more about the limits and capabilities from the link that we've added here about memory limits. Some other hardware details before we wrap up the hardware stuff is the accelerometer is available on all phones and is directly accessible through the Unity APIs. In fact, we're going to show you in a little bit how you can use the accelerometer to control our sumos moving around.
That's right.
Another thing too is you got to watch out because there's other things on the phone like the gyroscope, for instance, that are optional hardware and aren't available on every phone.
Right, that's right. So you can't necessarily rely on the fact that they will be there, but you could provide support for them if they were there on
Exactly,
those phones.
but you want to make sure you do at least some sort of check before you start to go ahead and use these devices or these hardware that's options that are available. Yeah. So that's a little bit about the hardware. It gives you a little overview of what you're working with, getting started and stuff. Kind of lets you know you don't want to go too overboard. Like I said, you shouldn't be spawning a million trees in the middle of nowhere, right? And expecting it to run well on the phones. It's just not going to happen. No phone can support that many meshes at one time. Not yet. Yeah, they're working on it, right? Okay. So let's dive in and we'll take a look at actually building the build.
Right, for the phone, which is different than what we did previously for the the Windows Store build. Yeah.
And again, it's very simple. It's not too difficult. So we'll jump into Unity here.
Yeah, there's a couple different options and other things that are specific for the hardware, just like when you go under any of your other player setting tabs and so on. So we'll just take a look at those.
So I've got Unity open here. And if I go in and I go up to my file, just like I did last time, I'm going to go to my build settings. But this time, instead of having it set to the Windows Store apps, I'm actually going to set it to the Windows Phone. So you see here Windows Phone 8. I click that. And if I click Player Settings, it's going to bring me up a list of options that you can then use on there. I'm just going to move my taskbar because it seems like it's getting in the way. There we go, Auto Hide. That's a little better. Okay, so there you go. So I've got over here in my inspector section. If I go here, you got resolution and presentation. Now this is kind of important on a phone, right? Because on a phone you can move this around a lot. People might want to play in landscape mode or portrait mode.
Or you might need to enforce one or the other.
Yeah, and that's exactly it, right? So for our game, it's not going to make much sense to play it in portrait mode. It's going to make our sumos look pretty skinny, right?
That's no good. Can't have that.
And sumo wrestlers generally, they're not very skinny. So we want to make sure we're running in landscape mode. So you can go in here in your default orientation and click the drop down. And you'll notice you got things like portrait, you got portrait upside down, you got landscape left and landscape right. And of course I've selected landscape left. Personal preference really. Of course, if you want to be able to make it so that they can rotate it, you just set it to auto-rotate, and then you're going to have to do some coding to actually check what orientation they're set in, and maybe do some scaling effects or something like that to support it.
If required. Some games don't even require it.
Yeah, exactly.
That's true, yep.
In here, again, you can't touch the icon in here. Splash image, same thing. But if we go into our other settings, much like the Windows Store build, we have the ability to set a few things up. So first up is static batching. Right, we can change that on and off, dynamic batching. And then we get back to our accelerometer frequency. So again, you could set it lower, if you just want to know where the object was, like, a lot of cycles ago.
Some augmented reality games only need to know a general area or a general what's going on every so often for other purposes other than gameplay directly. It could be where to spawn something else and so on. So it just needs to know the orientation, and then it's going to create something in that orientation versus you're actually moving the guy around with the gyroscope or the accelerometer on its own.
Yeah, so it defaults to 60, which is a good frequency to have if you're going to be controlling a player or something like that. If you set it to 100, obviously it's going to be better precision, but it's going to drain the battery pretty quick on you.
Yeah, so there's a bit more power being drained because it's pulling that accelerometer in all those directions every cycle.
Yeah, so, things to consider when you're building your game, how much do you really need to, data-wise, do you need to know where the object is or moving the object around, that type of thing. And then, of course, you've got things like you can optimize your mesh data, which may or may not be a good idea, depending on your game. If you're running on a phone, obviously, memory's important, and, maybe optimizing the mesh data would be a good move.
Yep, but at the same time, if you don't have very many meshes, you could leave it at a little more high detailed for the one or two characters you're only ever going to have on screen at a time, and that'd be fine as well, yeah.
Exactly.
But it's there, it's an option, and you can play with it.
And again, that's shared across multiple platforms, so if you set it here, you're setting it for pretty much all the platforms that you're supporting. Okay, so once you've got all that set up and you're happy with your settings, you're just going to go back over here and you're going to click Build. When you click Build, again, it pops up the File Explorer. And you can look here and see that, of course, again, I've got mine all set up the way I like it because I don't like things randomly put places. So I've got Windows Phone Builds as my folder. So if I go ahead and click that, and click Select Folder, it's going to go ahead and it's going to build it out for me. And again, because we don't have too complicated of a game, it's not going to take too long, so we don't need to do the magic of television.
And now the turkey is perfectly cooked.
Yeah, exactly. So, so once it's done, it's going to pop open our Explorer here again, and I'm able to go inside, and this is where it actually stores my Visual Studio solution. So you can go ahead and click that, and of course it's going to launch Visual Studio for us. In just a moment. There we go. So yeah, there we go. I've got, my newly created build. Ready to go, and you can see I've got my main page XAML, which has its code behind in there. And a few other things that I thought I'd point out while we're sitting here is the assets. Now, you might have noticed that on the Windows Store build, we had the option to do this inside of the Unity player.
Right.
Right? With the Windows Phone build, we don't have that option. So you would actually have to do it inside of Visual Studio here. So, you can actually set your tiles for whatever tile you're looking for, right? You could do your splash screen. It's down here at the bottom. And again, these are things that you have to change before you push to the store. You can't use Unity's default one. Obviously, they've copyrighted their logo, right?
So it'll be bounced back, and Microsoft will just ask you, please.
Yeah, will you please update your tiles, right, or your splash screen? So
which again, it's nice that you get that feedback as opposed to it failed. Okay, thanks.
Yeah, so definitely something to consider, right? Before you do this, we usually do a checklist. I have the checklist beside me. Have I changed all my tiles? Have I changed my splash screen? Have I done the things like handle the back button? Have I passed all of the things that I need to do, right? So just a good thing to keep in mind. So there we go. And now I thought, just for the sake of reiterating what we've done before, I'm going to show you how to bring in your assembly.
Okay.
So, I don't like to jump between IDEs, like I said before. I like to work in one IDE. That way I'm not, constantly alt-tabbing and burning out those two fingers of mine. So what I do is I just go up here. I'm going to go to Add, Existing Project. And it's going to open back up in here. And as you can see, I've got my assembly again. And I can select Assembly C#. Go ahead and click Apply, or Open rather. And there you go. My assembly is now inside of my Sumo Blocks Windows build. So if I want to change anything in my game controller or my AI controller or something like that, I can go ahead and do that there. So, you know, I'm not going to hook this all up to the device, but once you have it set up and ready to go, you're going to go up here and you're going to click the Run on Device. And what will happen is if you've got your device plugged in and unlocked, like we said before, you need your developer account so you can actually unlock the device.
That's right.
Right, so once it's unlocked and able to be used for development, you're going to go ahead and click play there once it's plugged in. And you also have to have it unlocked on the keys. Like, so, you know, if you have a password on your phone or something like that, you must make sure that it's open and actually on the home screen before you actually try to push the
Right,
build.
otherwise it won't have a connection because it's not accepting any input from the external sources and so on. So make sure you punch in your key or just turn off your password. That's usually what I do for development. I just disable the asking any of that kind of stuff on whatever platform I'm working on until I'm done, and then I can re-enable it afterwards.
Yeah, exactly. But yeah, just make sure you're on the home screen like this before you actually click the play button or run button. Otherwise, you'll have a little error that pops up that says we can't find your phone, or actually I think it pops up and actually says your device is locked.
Right.
So then it kind of warning you unlock your phone, right? So that's it. That's as easy as it is to build
for the phone,
right? To get that built into Visual Studio, to get your solution and get in here and start working. So let's go back into the slides real quick. So it takes a second to load up there. And we'll talk a little bit about the back button. Like I had mentioned before, handling the back button is a certification requirement. If you do not handle it, you're not going to pass certification. Right? And I got my little sad face there. And I just put this image in here so you could actually see what I was talking about, because I knew that the resolution, you know, from the distance of me holding it up, you might not actually see it. It's the button that looks like an arrow pointing backward.
Right,
Obviously.
so there's your back button.
Yeah, so that's the hardware back button. Now, some guidelines around this back button. Obviously, if you've got something like a menu system in your game, you want this back button to be contextual. You want it to basically go to the previous menu, right? So if I'm on the main menu and say I click achievements, and I'm in my achievements and I'm looking around, if the user clicks the back button, it's best practice to go back to the menu that they were previously at, right? The user might get a little annoyed if you're in the achievements and I press the back button and suddenly I'm out of the game. That could get quite annoying pretty quick, right? So that's something to keep in mind. If you do have a menu or navigation system in your game, make sure that this back button is going back to the previous state that they were in that navigation system.
Yeah, and that's a little bit of a departure from some of the other devices. They just have one catch-all, get me to the home screen button, and that's it. But
the Windows Phone has that as well.
Exactly.
It's the Windows button, right? So if the user does want to drop out of the game completely, they can just press that middle Windows button, and they're back to their home screen, right?
And so it's just something that the other devices don't have, that's all I'm saying. So that it's nice to have that back button, because the gamers expect to be able to shunt out of the menu a little bit faster without having to find where the little X is somewhere on this game, and it gets a little bit
And it saves you a little bit of screen real estate too,
It does,
right?
yeah.
So that's a nice thing. Another thing too is if you've got like a dialogue. So say you walk up to an NPC, you're talking to the NPC, and you press the back button, it shouldn't exit out and go out of the game or even out into a different menu, right? You should just literally close that dialogue or that pop-up, whatever it might be, right? So there's things to consider when you're deciding how am I going to handle these back buttons, and it should be handled differently depending on where the user is in your game. Right. Again, if you're not in a dialogue or you don't have a navigation system, like our game doesn't have a navigation system.
That's right.
We don't have a dialogue boxes pop up. We don't have things like that. So if we press the back button in our game, it should just exit the game.
Okay.
Right. So these are some of like the guidelines behind what you could do with it, right? Each game is obviously going to be have its own way of implementing it, and you're going to have to look at that when you're deciding how you're going to handle these.
And as long as you handle the back button, it's okay, but it doesn't have to be specifically only handled in that case. All right. Okay,
so I'm going to show you guys how to handle this back button press, but before we do that, we actually noticed, and Brian pointed this out, that if we're using our game and you're playing our game, right now we're only saying if you press the enter key, you can continue. Well, that doesn't necessarily work on the phone. So we kind of accidentally, we were kind of messing around with it last night and thought, well, we should add this. It was kind of funny. Last minute changes always work out well. So we decided, we're going to add it so that you have to press the enter key. And the reason for this is because, if you click your mouse or something on the other version, it was just cycling through and you weren't able to see the you win, you lose situation, right? So what I'm going to do is I'm going to actually go into my code here. If it'll let me exit my, there we go. And I'm going to go into the code for my my game controller. And since I'm already have this open in Visual Studio, it's going to make it a little easier. I'm not going to jump into Mono to do this. I'm just going to do it right inside of Visual Studio. So if I scroll down here to our update state, where we have our win-loss conditions, this is where we've actually put if the input is if the key's down and the key matches the return key,
yep.
Then we go ahead and reset.
And if you're wondering what the return key is on a most keyboards, it's that enter key that's on the keypad, or not the number pad, but the key section of where you would type. Mm-hmm. But that, for those that are Mac users, they know exactly which one it is, I'm
yes.
sure, because it's actually there.
Okay, so what we're going to do here is we're going to set up so that if we're on the Windows Phone, we're going to accept any key, which is basically the same thing as saying have they tapped the screen, right?
Yep.
So
any input would be
any
nice.
input will be fine for us, right? So I'm gonna, I love typing live here, but so what we're gonna do is we're gonna set this up so that instead of using a preprocessor directive like we have in the past for a lot of these things,
right.
I'm gonna try a different technique, which is actually going to ask what application platform am I on?
Okay.
So if I say application platform is equal to our runtime platform. And we're on, if you scroll down here, you'll see we have a bunch of them, but we have Windows Phone Player. There we go. Windows Phone 8 Player.
So again, this is a Unity define that's already existing in your projects. You can use it. It's not a Windows-specific thing. It's a Unity thing, and we're just taking control of it effectively.
So what we're doing here is we're basically saying only run this code if we're on the Windows 8 Player. So then inside here, I'm going to put another conditional that says if input any key, run this code. And in our case, it's just going to be reset. Can't spell. There we go. And that's it. Okay. Well, what I could do here too is I probably should put else if, just to make it a little cleaner. But there we go. So now what we've done is effectively set it up to have two different cases. One if we're on the Windows 8 Player, and one if we're not.
And of course, that's only in the win state, so then you got to take that down.
And being the guy I am, I'm just going to go ahead and copy it because I don't like to retype a bunch of stuff. So there we go. I copy it down here. Go ahead and change this to else if. And there we go. So now what will happen is if I play the game, and I win or I lose, and I touch the screen, it's just going to go to the reset, and it'll basically go back to the start and reset everybody where they are, and you've seen that. You demoed the code at the very beginning for us.
Right. Now, what is the differences between doing it this way versus doing the preprocessor method? What really is the key technical difference there that's going to happen?
Well, the reason I'm doing it this way is, say I wanted to support more than just the Windows 8 Player.
Sure.
Maybe I want to have it so that I'm supporting other platforms. Well, I can just basically say, and if I'm on another platform, so we'll say application, platform is equal to, and this is going to get really long, so I'm just going to put it on the next, there we go, next line. And maybe I'm running on a different platform, say Xbox 360.
Sure.
There we go. So now this is basically setting it up so that it's a dual case, right? So I'm able to say if I'm on Windows 8 or on the Xbox 360, do this. Whereas if I had a preprocessor directive, I can only do one at a time.
Correct. Okay.
So now I'm going to have to add a whole bunch of preprocessor directives in here.
With the same code
in it, and that just seems like a lot more work than we really need to do.
Okay, and I mean the other difference is, of course, that this is now live in your code. So when you do compile this in and build it out, it will be there running on your phone or on any platform for that matter. It doesn't get removed pre-compile time. So that is another difference. Using the pre-compile flags, that code can be stripped out and will not be included in your end executable or whatever you need to put on that platform to get it to run. Whereas in this case, it actually is there. It is being evaluated. So that is a absolutely minor performance difference, but it is there.
It is a performance
It's just
difference,
something
yeah.
to be aware of. It's on there, especially when you're dealing with really low-end platforms. You may want to strip out every single thing you can, especially if it's during an update loop or something like that where it's literally hitting it every single frame. You may not want to do it in that manner, but now you know both ways that you can do that kind of segmented code for different platforms.
Exactly. Okay, so I'm just going to remove that line there. And I promise I will update the source on that GitHub shortly after here with this line, just so if you guys do want to be able to use it on the phone, it'll work just fine. So yeah, that's something I wanted to show before I started talking about the back button press, just because I knew it was something that we had kind of skipped over and probably should highlight, right? So let's go back. I'm going to actually open up my main page, XAML.cs, which is the code behind for my XAML. I'm going to zoom it out so you can see it nice and big there. And this is where we're going to actually catch the event of somebody pressing the back button.
Okay.
And what's really nice is this is all stubbed in for you automatically. As soon as you create a Windows Phone build, this is already in there for you. And if we scroll down near the bottom, you'll see right here we have this function that basically says if the phone applications page has a back key press, do this, right? So this is our event handler.
Okay.
Right now it's set up to say, you know, if it's a cancel, so basically they've got it set up so that it's an escape key, right? Now,
so it'll immediately leave the application.
Exactly.
Okay.
So we're going to do a similar thing, but I just wanted to show how we can actually call code inside of our game. So what I'm going to do is I'm going to uncomment this line. Tongue's getting all tied up here. If I go ahead and got my instance of my game controller,
okay,
and I say .quit, it's pretty much the same thing as the line above, but in our case, we're actually just going to handle that code inside of our game controller. So what happens is when it catches this back button press, it's going to go into our game controller, and in that instance of our game controller, and it's going to call the quit function.
So now it's accessing the code we had written maybe in Mono in a C# script.
Yeah, this is our code from our assembly, from our Unity, right?
Okay.
So again, we're passing data back between the two of them, right?
Right.
So basically what we're saying is if you see this, just quit the application.
Okay.
Right? Now again, like we said, this isn't a best practice situation because if you do have a menu system or something like that, you're going to want to make sure that you're handling it in a proper context. So if you're in a menu, go back to the previous menu, dialogues, exit out of the dialogue, you know, that kind of thing. But for our game, because it's such a simplistic game, we're able to go ahead and do that. So I thought, you know, I'll pop it up on the phone and actually show you guys it playing, so you know you don't have to take my word for it. You can actually see it. So here we go. We've got, you know, it loading there, and it shows a little loading bar that we'll show you later. I know the resolution's really bad, but all I really want to show you is the fact that I'm playing, I'm moving around, right? I'm using my accelerometer. I press the back button, and I'm out.
Yeah.
Right? Simple enough, very easy to implement. It's something that you have to do to pass certification. But again, make sure you're handling it in a way that's appropriate for your game.
Right.
So yeah, that's the back button press. So I'm going to jump back into our slides here.
Accelerometer's up next, because I saw you were waving that phone around.
Yes, accelerometer's up next. So we'll take a quick look at the accelerometer. There we go. Just give it a second to load. So, you know, using accelerometer, it's obviously a simple and fun way to, you know, add an extra layer of interactivity with your users. If your hardware's got it and your game, you know, suits it, not every game's going to obviously suit accelerometer input, but a game like ours actually does. So why not take advantage of it? Sure. Right? You know, the implementation of this is very, very simple. It's actually the same on our device as it is on any other device inside of Unity, right? So the accelerometer for the code that you write for the Windows Phone platform is the same that you would write on an Android platform or an iOS platform. Sure. So you could write this code once, and it's portable to all devices, right? Perfect. So that's really nice. Yeah, it's a, it makes it a pretty much verify it and move on situation, right?
Yep.
Make sure it works, check it, test it. If it's good, move on.
So yeah, there's the axes. In case you're wondering, this is the way we view everything in terms of the accelerometer and the Windows Phone device itself. If you were to hold it flat, like you're setting it down on the table and you can see the screen, then Z is up. Z is negative in that direction, coming up from the screen. Whereas looking down into the screen, it would be positive, and X would be your axis for when you're holding it in sort of portrait mode, whereas Y would be your left and right axis when you're holding it in landscape mode. So that's the common sort of layout and functionality. The same typically holds true for many 3D video games and modeling programs. Going into the screen is usually your Z depth in either negative or positive. People usually don't agree on that part, but because we usually hold phones upwards in a portrait mode, X has been defaulted to the left and right, and Y is your vertical sort of direction, and that's pretty typical in terms of where Z, X, and Y relate to one another. So there's no real differences there either.
Okay, great. So you know what? Let's dive into the code, and we'll actually take a look at what I set up inside the code to handle this input system.
Okay.
So we'll go ahead and I'll jump back into the code here.
And again, this is just for controlling the sumo wrestler running around on the mat using the accelerometer, as opposed to trying to shove him around with your finger or something like that. Didn't want to put a thumbstick control on it and take up any screen space. In this case, it's simple controls, left, right, up, down. So we just wanted the tilt to move your guy around.
Yeah, it just felt good for our game, really. Right. So I'm in here in Visual Studio in my game controller class again. And if I scroll down, I just got to find it here. Well, actually, I'm sorry. I'm in the wrong spot. I'm actually supposed to be in my player controller because obviously this is for controlling the player, so it would make sense that it's in our player controller class. So if you look here, again, you watch us all through it, but we have our movement speeds and all stuff like that set up. If we scroll down a little bit, this is where we have our update. And in our update, this is where we're going to actually take the input and do something with it, really, right?
Yep.
And in this case, we're going to move our sumo around based on our input. So again, we've set this up so that it's using the application.platform situation. And again, the reason for this is the accelerometer is the same on all the mobile devices. So you could
stub in your other phone devices that have an accelerometer that are going to use this control right into that if statement, and all of them now are controlled in that way.
Exactly.
And we're good to go.
Yeah, so you write it once, you can use it on multiple platforms.
That's right.
So what we're saying here is if you're on the platform of the Windows Phone 8 player, we're going to run the code that's in this if statement, and basically all we're doing is saying, the player speed times an acceleration on the X times delta time, which makes it a little bit smoother. And then we just translate our transform, which is our player, by that amount, right? And then the same thing we do on the Z. So that way we can move them back and forth and right and left. Very simple, right?
Yep.
And then if we're not on our Windows 8 platform, we're just going to do the same. There's the code down here in the else, which is basically just using our default input, which could be WASD, or it might be, a game controller, whatever you've got set up inside of Unity, right?
That's right.
So yeah, that's pretty much it. That's how you set up using an accelerometer.
Yeah, and that's the same again for any platform. It's just access Unity's input manager, grab out what you need from the accelerometer in whichever axis that you're worried about, and apply it, and that's it. So there's no changes you need to make specifically for the Windows Phone platform versus any of the other accelerometer supporting platforms. It's all handled already in Unity. You're just accessing that input in case you haven't done any porting to any phone before. So that's why we've highlighted that.
Yeah, and I thought it would just be kind of a cool feature of the phone to kind of point out. And again, if you're doing mobile development on other platforms, you've probably done this. And I just wanted to really highlight the fact that it's simple and easy. It's a verify move on situation.
Yeah, and if your game only works on the phone anyways, and you already just use accelerometer input, then you don't even have to do anything. There's no code you need to change, nothing to add, because you're already asking the input manager for that accelerometer to do whatever you need to in your game. So you need to do nothing at all in this case, and it's supported already on the Windows Phone platform. Test, move on.
Exactly.
Yeah.
So that kind of wraps up a little bit about the Windows Phone. You know, we took a look at what the Windows Phone was. You know, we saw what's available to you. You got the same sort of tile system, things like that. We did a quick look at, you know, the accelerometer, obviously.
Yep.
And we talked about handling the back button, which is the only major concern outside of the tiles and the splash screen changes that you need to do before you actually push to the store.
And the tiles and the splash screens are across both platforms, so we're going to do them in the next modules as an overview just together, so we get to see all the, you know, the way you can access and talk to your users a little bit more right through the OS and through those kinds of features.
Exactly. Is there any questions that we could answer right now?
I think most of them have already been answered, sort of.
Our support staff's just rocking that chat
Yeah,
for us.
well, and we had the slide with the accelerometer and stuff explaining a couple things as well. So it looks like we're good at the moment. If not, I'll read through some of the ones near the top and maybe hit you up during the break in the chat.
All right, sounds good. So I guess we'll take a quick 10-minute break. When we come back, we'll talk a little bit more about the live tiles.
Perfect.